So the very last gas law you're going to learn about is the ideal gas law. And the ideal gas law tells you that pressure times volume equals N times R times T. N is the number of moles, R is a constant, and T is your temperature. And so we'll either call this the ideal gas law, PV equals nRT, or as a nickname, just PIV-NERD. Okay? So as a reminder, P is for pressure. The units for pressure need to be in atmospheres. Okay, so if you're given millimeters of mercury or you're given kilopascals, you got to make sure to actually convert that. V is your volume, and volume has to be in liters. N is your number of moles, and so that's going to be in moles. The reason why your pressure and your volume, your number of moles, and your temperature have to all be in certain units is because of your R. Your R is your gas constant, and it is 0.0821. Notice the units are atmospheres times liters over moles times Kelvin. And so that's why your pressure needs to be in atmospheres, your volume in liters, your N, your number of moles in moles, and then temperature, T, has to be in Kelvin. Okay, so just make sure, unlike your other gas laws where the only unit that you had to be concerned about was making sure that your temperature was measured in Kelvin, for these problems, all of your variables have specific units that they must be in. So just make sure you're careful with that when you're doing these problems. So let's look at an example. It tells me I have 4 moles of a gas at a pressure of 4,256 millimeters of mercury and a volume of 12 liters, and it's asking what is the temperature, all right? So I'm going to use PV equals nRT. My issue is that right now my pressure is in millimeters of mercury, so I need to convert that right now into atmospheres. So I'm going to plug that in. I'm going to put millimeters of mercury on bottom. I'm going to put atmospheres up top. For every 1 atmosphere, I have 760 millimeters of mercury. So I'm going to take 4,256 and I'm going to divide that by 760. And what I get is 5.600 atmospheres in order to maintain significant figures. Now, I've got my pressure in the units it needs to be in. My volume is already in liters, which are the units that I want. I have moles, and it's asking about temperature, so now I can plug everything in and solve for it. So I'm going to plug in the 5.600 atmospheres for my pressure. I'm going to plug in 12 liters for my volume. I'm going to plug in 4 for my number of moles. I'm going to plug in 0.0821 for my R value, and I'm solving for T. Okay? So make sure when you're doing this math, be careful. You're going to take 5.600, you're going to multiply that by 12, then you're going to divide that by 4, and you're going to divide that by 0.0821. Or you could take 4, multiply it by 0.0821, and whatever you get there, that's what you're going to divide the 5.600 times 12 by. Whichever way you want to do it, I actually divide by 4, and then I divide by 0.0821. That's what I just, in order to keep it in my calculator and keep it simple. Okay, so my temperature, remember, since my units for R are going to be atmospheres, liters, moles per mole Kelvin. That tells me my temperature that I got, which was 204, that's going to be in Kelvin. Now notice that as far as significant figures are concerned, I have one significant figure for the 4 moles, from the 4 moles. Therefore, I need to round this answer so it only has one sig fig, and so that answer would be 200 Kelvin. And that's your ideal gas law. That's all there is to it. So it's really not that bad. Now, we can take this idea and expand on it a tiny bit. And what we're going to do now is we're going to use your ideal gas law and learn how to determine the molar mass of a gas. All right, so in this problem, it asks what's the molar mass in grams per mole of a gas if a 3.16 gram sample of gas at 0.750 atmospheres and 45 degrees Celsius occupies a volume of 2.05 liters. So this problem might seem super complex until you realize you're going to be having 2 different problems. The first problem you're going to do is you're going to be using the ideal gas law in order to solve for moles. So you're going to use your pressure, your temperature, and your volume to solve for moles. Once you know your moles, in order to get into molar mass, which by the way, the units are grams per mole or grams divided by moles, all you have to do is take your mass, which was the 3.16, divided by the number of moles that are involved, and that'll give you your molar mass. So let's actually do the problem. So I'm going to use PV equals nRT. I have my pressure already in atmospheres. I have my volume already in liters. I'm solving for N, my number of moles. I know my R is 0.0821, and my temperature right now is in Celsius, so I need to convert that into Kelvin by simply adding 273. So I plug in all of my values. Okay? I'm going to take 0.750, multiply it by 2.05. Then I'm going to divide whatever I get for that product by 0.0821, and then I'm going to divide that by 318. And what you get is your number of moles, which is 0.05889 moles. Now that I have my number of moles and I have my mass, you can determine your molar mass. All you have to do is take your mass, 3.16, divide it by 0.05889. That will give me grams per mole. And so what I end up getting for my molar mass is 53.7 grams per mole once I take into account significant figures. Okay, so the only thing that I've added to this problem, the only reason why this is slightly different from just an ideal gas problem, is the fact that I'm now asking you to take your moles and apply it specifically in order to determine your molar mass. And in order to do that, all you have to do is take your mass, divide by the moles that you calculated, and there's your molar mass.